Good morning, everyone. Thank you, Session Chairperson and CST for giving me the opportunity to talk about Linde's Starbridge technology. What is Starbridge? It is actually the electric furnaces for production of ethylene. I will touch upon three aspects in my presentation. First, giving you an overview, which is the introduction part. The second is the demonstration plant, which has been built at BASF site in Germany. And third is the commercial design, which we are ready to offer to the industry. To start with the introduction, as such, petrochemical accounts for 5% of the CO2 emissions globally. And when it comes to the furnaces, the enormous amount of CO2 is being emitted into the atmosphere to the tune of 300 million tons every year. This was the problem, and the three companies came together, which is BASF, SABIC, and Linde, to address to this problem, and came up with the two concepts to be developed for offering e-furnaces as a technology, and named it as Starbridge technology. It is a licensed technology, and it will be offered by Linde. What are these two options which we have? We try to evaluate and try to, in terms of which is the best one, but still there is a lot of learning which needs to happen to come to a conclusion that which is better. So we evaluated both the technologies, which is Starbridge indirect as well as Starbridge direct technology. When it is Starbridge indirect technology, the resistive heating element is on the walls of the furnace, and the electricity is applied to the resistive heating elements, which is on the walls, and the radiation happens, because of which the heat transfer happens, and the heat is being transferred to the coils. Whereas in direct heating, the resistive material is directly imposed on the coil itself. These are proprietary coils and are much efficient in many ways than the indirect. But nevertheless, I cannot conclude that any of the technology is better at the moment. Though direct heating has some advantages, which we will cover in coming slides. So what was our target? Target was to reduce the CO2 in terms of avoiding it by 90 to 95%. Why 95% or 90%? Because some amount of the coke formation is there, and that will occur because of the inherent process of cracking. So 5 to 10% you can say that CO2 anyhow will be emitted in the form of coke. Then the second was that it has to be flexible, it has to be easily adapted by the industry, and the third one is that it has to be easily, I will say, integrated with the existing crackers, as well as technology ready for the feed and EPC execution. These were some of the highlights or the goals which we had kept in front of us to achieve by providing this technology. Now, where we are in terms of technology development, it's done. We have worked with various partners, various vendors. Earlier, we used to understand burner management, flame infringements, or hotspots. Now we are more understanding electric equipments, transformers, thyristors. So those knowledge transfer was there. And after that, we came up with a demonstration plant, which is, as I said, in BSF, Germany. And this is in operation for almost now more than a year. And we are learning, still learning about the behaviors of the furnaces and how one option is better than the other one. More about the demonstration plant. It's a 6 megawatt electric power is being supplied for a feed of 4 ton per hour of naphtha, producing cracked gas, and which is being separated in the commercial scale BSF plant adjacent to it. So it's a running plant in which the cracked gas goes and is being used for producing ethylene, propylene, and other valuable components. Here, the electricity is being used, is renewable in nature, and both direct as well as indirect heating will have preheating concepts as well as cracked gas cooling as a part of the furnace offering. The basic learnings which we had in the demonstration plant was actually we wanted to validate our tools and methods which we have adopted. We have first time done e-HYBIZ, which earlier for the process we used to do only HYBIZ. For the electric verification and the safe operation, we have done e-HYBIZ also. Other than that, TUE was involved into the certification of the entire demonstration plant. We have interacted with, when it comes to procurement, we have interacted with various vendors, especially electric suppliers, telling them our requirement and they meeting our requirement with their innovative designs for both direct as well as indirect heating technologies. Factory acceptance test. In terms of construction, we have learned more about assembly procedures. We have developed them in terms of tolerances or fits for the construction which we have adopted in this demonstration plant. Apart from that, during commissioning, sequence procedure with respect to electric elements, transformers or thyristors, star delta connections, those were incorporated in our sequence procedures, and ramping rates extra were analyzed. And with respect to operations, run times, yields, I will say that slightly better than the conventional furnaces we have already achieved. In terms of, I will say, different behaviors, transition behaviors, we have learned how it operates and how best it can be operated. Then the maintenance efforts for electric components as well as for the coil or for the entire furnace, those aspects were discussed and learned. Now, as the demonstration plant is already operating since last more than 1 year, so we have commercial design available and we are offering to our clients, esteemed clients. Just to tell you that we are receiving, I will say, queries or inquiries with respect to study of various small-scale furnaces, as well as add-on furnaces to the tune of, say, around 40 to 80 KTPA, a single furnace. And that's where we are working with our esteemed clients. To start with the commercial design aspects. We have the radiant box design which is available. We can offer both direct as well as indirect heating solutions. We have feed integration. It can be done with power. It can be done with steam. That both options are available, and we do offer it on case-to-case basis to our clients. Then the process safety aspects have been taken care of in terms of in case of rupture of any of the tubes or any malfunctioning of the furnace, what kind of safety provisions are there in the furnace so as to address to them. And power supply concepts in terms of thyristors or transformers or electric supply systems, we have come to a conclusion. And general arrangement in terms of the furnace geography, and good to tell you that we can fit into the location, or the size we have come up with is identical to what a commercial scale furnace size will be. We have different options, and we can offer them as far as general arrangement is concerned. To give you some aspects, when it comes to heat integration, you can see that we can use steam or power, both for preheating of the feed. And then we have our own flex feed exchangers. It can be clubbed with the secondary or other heat exchangers as per the need. With respect to maintenance aspects, you can see over here, the blue one which is shown over here, it is for removal of the coil, and based on the requirement, we can open up the radiant box and remove the coil. Let me tell you that in both indirect and direct concepts of Starbridge, we have seen that the coil life is much, much better than the conventional, I will say, conventional life, conventional furnaces with coils. And as far as furnace or maintenance space is required for electrical components, you can see that at various places, we have left some space for the maintenance of electric components. So, as I conclude my presentation, I would like to summarize it that Starbridge is now a commercial design which is established and is available to our esteemed clients. Demonstration plant is integrated one, and it produces CAD gas so as to for production of real products. It's not a pilot or a lab scale plant. And we are ready to offer the feed and EPC execution for such electric furnaces under Starbridge technology. Thank you very much.